Monsoons. Finally, we have monsoons. Monsoons develop depending on sun exposure, and since they occur mainly within the tropics, in other words, the space between the Tropic of Cancer and the Tropic of Capricorn, we need to familiarize ourselves with the Intertropical Convergence Zone, or ITCZ. I made a video in May of 2022 on the Intertropical Convergence Zone that covers all the basics in some detail if you would like to know more. I'll leave a link in the description. In that video, you'll learn how the sun heating up the ground, creating rainy low pressure skies, which then sink around 30 degrees north and south to form high pressure skies, is not a permanent condition, for 3 reasons. The Earth is on a tilt, rotates on its axis, and orbits around the sun. This means that the solar concentration that creates that area of low pressure ranges from focusing on the Tropic of Cancer in July to the Tropic of Capricorn in January. That means that that area of low pressure will shift between the two, creating seasonal weather events throughout the year, such as, you guessed it, monsoons. Now for the big picture. We'll start in March, when the ITCZ is along the equator. As the year progresses and the sun is concentrating more of its energy towards Tropic of Cancer, so too will the ITCZ move to meet the area of solar concentration, bringing with it high levels of precipitation. Looking at a climate graph from India, you'll notice high levels of rainfall during the month of July as a result. The shift of the ITCZ to the north in July leaves the Tropic of Capricorn lacking the solar concentration it needs for low pressure, which means that high rainfall enjoyed in the north isn't around in the south, so the south will experience a dry season. Moving through the year, the sun will begin to concentrate its energy towards the Tropic of Capricorn by January, and now the south will experience a rainy season, while the north will experience a dry season. This can be noticed in Indonesia's climate graph, showing high levels of rainfall in January as a result. As a case study, we're going to focus on India as it's a primary figure in the famous South Asian monsoon. But keep note that monsoons occur in many different continents, but follow the same principle. Let's get started. In summer, India is exposed to lots of heat by the sun, creating an area of cloud generating low pressure over the land and an area of high pressure over the water. The critical detail is that the land heats up faster and more effectively than the ocean. And since high pressure seeks low pressure, the warm air draws in humid southwesterly winds from the surrounding oceans. This humid air reaches the warm land and rises and condenses into even more clouds. Additionally, to the north of India is Nepal and the renowned Himalayan mountains. If you recall when we studied Chinook winds, mountains are notorious for creating relief rainfall on the windward side and rain shadow on the leeward side. So you've got additional cloud formation along the windward side of the Himalayan mountains. So to recap, you've got the sun heating up the land, creating low pressure, causing warm air to rise, condense and form clouds. Next, you've got moist humid air being drawn in from the oceans, reaching the warm land, rising and condensing and forming more clouds. And then you've got mountains acting as a ramp that launches air upwards, gaining altitude, condensing and forming even more clouds. The significance here is that monsoon season has all 3 of these sources of rainfall occurring at the same time. These heavy rains can last from May through to September, and are typically seen as a welcome blessing to the land, as many locals depend on the monsoon for agriculture. However, the South Asian monsoon has 2 seasons: the summer monsoon that approaches from the southwest, and the winter monsoon that approaches from the northeast. The first thing you need to learn about the winter monsoon is that it is the opposite of the summer monsoon. This is because the ITCZ is now focusing its solar energy along the Tropic of Capricorn, meaning the low pressure skies are above the Indian Ocean, and now high pressure skies fall upon India. This high pressure prevents the formation of clouds entirely, and brings about a dry season. The high pressure skies over the land now seek out the low pressure skies over the ocean and blow northeasterly. This is significant for our pilot, since depending on the season, summer or winter, will determine what kind of winds are blowing, southwesterly or northeasterly, and the degree of cloud coverage and visibility and intensity of rainfall that you can expect. So if you're flying over India during summer between the months of May through to September, you can expect low-pressure storms and high cloud coverage over the land, clear high-pressure skies over the ocean, and with southwesterly winds blowing. And if you're flying over India during winter between the months of October through to January, you can expect clear high-pressure skies over the land, low-pressure storms and high cloud coverage over the oceans, and with northeasterly winds blowing. And that's monsoons.